covering the material. We will get into chapter 13 tomorrow, probably deep into it, but it won't be on the exam on Monday. And I will leave some time, like tomorrow from maybe 1:30 to 1:30 on, I'll start entertaining any questions you have on chapters 10, 11, and 12. This homework assignment, I'll get back to you before the exam, so you might be able to pick it up at 11 on Monday or 10:30, something like that, Monday morning. All right. What we have left in chapter 10 is ethers. We got this here. We got one more reaction, dehydration. Yeah, this might take us to 15 minutes, but this would give you the information you need to complete question number 4, the dehydration of an alcohol. It is an elimination reaction. So you've learned now what we mean by substitution. You've learned what is meant by addition. And now you're going to learn what's meant by elimination. So dehydration is just what it says. We're going to lose, it's the loss of an H2O. We're going to lose a water molecule from a molecule. So let's take a real simple alcohol. Let's take this alcohol here, which is ethanol. This is ethanol, and we're going to dehydrate it. Usually, I don't know, there's sulfuric acid or something in here. Where's our water? We're going to get rid of a water molecule. Well, here's our water molecule, H2O. It's going to be an OH, and it's got to be a hydrogen next to it. Can't be this OH and that hydrogen. We're going to get it from the OH on one carbon and a hydrogen on an adjacent carbon. In ethanol, there's only one carbon next to it. And when this happens, it's really kind of the reverse of what we saw there before. This electron is going to collapse back into here. And these electrons are going to go down into here to form our water molecule. And what are we going to get? We're going to get a double bond there. So the dehydration of an alcohol, eliminating a water molecule from a molecule. And it's going to produce an alkene. So the dehydration of an alcohol produces an alkene. All right. Enter Zaitsev. We don't need to invoke Zaitsev's rule right here because there's no major and minor product. There's only one product. This is the only product you get from the dehydration of ethanol. But let's take a little bit more complicated alcohol. Not very much more complicated, but let's take even isopropyl alcohol. We're going to only get one product. But let's take a little bit more complicated one. Butanol. And this is going to be 2-butanol. So we're going to do the dehydration of 2-butanol. We've got a hydrogen here, and we have a hydrogen here. Got a lot more hydrogens. All right? I'm going to ignore all these hydrogens. Why these two? Because these are the only two that are on adjacent carbons. Okay? We got an OH here, and we're going to lose a water molecule. So it could either be that water molecule, which would put the double bond right there, or we could lose that water molecule and we'd produce the double bond there. You see the two options? So if we lose this, we get this. Plus water. And if we lose this, I'll put a square around it. We get this plus a water molecule. One of those is the major product and one of them is the minor product. This is the major product.
So it goes against the more cost.
Yeah, we gotta understand now. This is major. This is the minor. And usually on homeworks and different things like that, I'm going to say draw the major product from the dehydration of this particular alcohol. All right, and so Zaitsev. Am I spelling his name right? Yeah, Zaitsev. And I think he's also another Russian. I think that's another Russian chemist. Okay, what does he say? The product that gives the highest number of carbons attached to the double bond is the major product. Okay, now here's our double bond. Now we want to look at how many carbons are attached to that double bond. This double bond has a carbon here, that's one. Has a carbon over here, that's another one, that's two. This has two carbons on the double bond. This one only has one. Okay, don't count. Don't say how long the chain is. How many carbons are directly attached? See, these are hydrogens. Hydrogen, 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 one carbon. One carbon on the double bond. So this is the least substituted double bond. This is the most substituted double bond. It's the major product, the more stable compound. So it will predominantly dehydrate to make 2-butene instead of 1-butene. Here's another example here. This is 2-butanol again. 2-butanol. It's 3-methyl 2-butanol. So we could get this OH with this one of these hydrogens right here. That'd be a water, and that will produce that double bond right there. Or we could take this hydrogen and that OH, and we'll get a double bond right there. And that'd be that product. And now look, here's your double bond, and it's got one carbon on it, 2 carbons on it, 3 carbons on that double bond. It's highly substituted. This has got 3 carbons on the double bond. This one only has 1. I mean, don't count how big this thing is. There's only 1 carbon and 1 hydrogen here. This carbon has 2 hydrogens, no carbons attached to it. So there's 1 carbon on this double bond. This is your major product. This is minor. That's Zaitsev's rule regarding the dehydration of alcohols to form alkenes. Okay, let's take one of your, which one you want to do? Question 4. Pick one. Problem 4. 4D. Okay. 4D. Let's do 4D. This is the dehydration. So we got to draw it first. 4-chloro-2-pentanol. What's it say? Number 4 says, draw the major alkene product and give its name, formed by the dehydration of these alcohols. Use Zaitsev's rule to determine the major product. So we're going to have 2-pentanol. Oh, I need a double bond there. 2-pentanol. 4-chloro. All right, I'm not drawing all the hydrogens, I'm just drawing the 2 important ones to see. So we could eliminate that water molecule and get a double bond right there. Or we could eliminate this water molecule here. This OH would go with that hydrogen to form water. Wherever the 2 leave is where you get the double bond. So where are we going to get the double bond? Is it going to be here? Here. Yeah. Okay. So we're going to eliminate that water molecule. And we're going to get and here's what a lot of students do. They finish this off, but they leave off the chlorine. All right? Chlorine comes right on along with it. And why? Because now this double bond has 1 carbon here and another carbon over here. And that's your more highly substituted double bond. That's your major product.
So can you repeat that again? When you said like this one carbon there and this one carbon.
Yeah, here's your double bond. You have a carbon here and you have a carbon here. So you don't count these carbons. You're asking how many carbons are attached to these 2 carbons. 1, 2. And you don't count this carbon because this carbon is not attached to the double bond. It's attached to that carbon. How many carbons are directly attached? So the double bond really can only have 4 things attached to it. Are they hydrogens? Are they carbons? What's on there?
How would you be missing a hydrogen?
Pardon me?
Missing a hydrogen.
I'm missing a hydrogen right there. Yes.
How would you make the major?
So the major product would be is that right? 4-chloro-2-pentene. Okay. All right. Okay, I think I'm going to... So what we will cover tomorrow is ethers, thiols. In the 10 or 15 minutes, we will pick up on ethers and thiols. I think you have everything you need to do chapter 12 homework right now. And then we'll start chapter 13.